All right, so then the next part of this section 9 that we're going to talk about is solving quadratic systems through substitution. So we're going to do one more example where it is a linear quadratic system, and then we're going to do an example where it's two quadratic equations. But we are going to use substitution whenever we are solving for a quadratic system. All right, so we have these two equations here. Y is equal to negative x squared minus x plus 6, and y is equal to x plus 3. So since it's a system of equations, whatever x we have needs to be able to work for both the quadratic equation and the linear equation. So here we have y is equal to negative x squared minus x plus 6. So that means wherever I see y, I can substitute negative x squared minus x plus 6 in because they're equal to each other. They're the same thing. So then if I want to go ahead and try and solve this, I have y is equal to x plus 3. Well, wherever I see y, I can substitute negative x squared minus x plus 6. So we have negative x squared minus x plus 6 is equal to x plus 3. All right? And then from here, we have a quadratic equation because we have a power of 2 for our x. Whenever we have quadratic equation, we can solve it multiple ways, but we want to set it equal to 0, and we want to have our x squared be positive. So then I'm going to add over my x squared, add over the x, and minus my 6. So I'll add over the x squared, add over the x, and minus 6. So now I'm left with a positive x squared. X plus x gives me plus 2x, and 3 minus 6 gives me minus 3, and it's equal to 0. Right, so now once you set it equal to 0, you can see and try and see, is this something I can factor easily? Can I factor it? Can I not factor it? But you can use any method you want here. Remember, quadratic formula will work all the time. That's negative b plus or minus the square root of b squared minus 4ac all over top of 2a. That will always work. However, when I look at this, I know that this one can factor really quickly because this minus sign tells me that there's a difference, and there's a difference of multiples of 3 to have a difference of 2 are 3 and 1. So I know that this one can factor out pretty quickly. So I'm just going to use factoring. So this can factor out. This sign tells me that they're different. So I can do x plus and x minus. I'm looking for numbers that multiply to 3 to have a difference of 2. Well, that's 1 and 3. And then the larger number has to be positive because of this sign here. So it'll be x plus 3 and x minus 1 is equal to 0. And remember, anytime two numbers multiply and equal to 0, that means one of them has to be 0. So x plus 3 is equal to 0, or x minus 1 is equal to 0. And then to solve for this, I'm going to subtract over 3. So x is equal to negative 3, and I'll add over 1, or x is equal to 1. All right, so that means that x can be negative 3 or 1. But now I need to find, well, when x is negative 3, what is my y value? So I need to substitute these in back into both of these, need to go back into one of our original equations. And we need to figure out, well, when x is negative 3, what is y? So when x is negative 3, y is equal to x plus 3, or negative 3 plus 3. So y is equal to 0. So one of my solutions is the ordered pair of negative 3 comma 0. And then for when x is equal to 1, I need to substitute that in as well. So y is equal to x plus 3, or y is equal to 1 plus 3, and y is equal to 4. All right, so that means when x is equal to 1, y is equal to 4. So those are my two solutions, my two ordered pairs. You cannot just say that x is equal to negative 3 or 1, and y is equal to 0 or 4. You cannot just say this. This is not correct. All right? Because when x is negative 3, y has to be 0. And when x is 1, y has to be 4. When you write it like this, you're saying that it can be any combination. That when x is negative 3, that y will be 4. So when you write your answers, you must write them as your ordered pair like I did here. All right? So that is the solution to this system, negative 3, 0, or 1 comma 4. All right, so that is the solution here. There's one more example that we're going to do before we get into quadratic inequalities. All right, so then the next example that we have is now when we have a system of quadratic equations. So now both of these are quadratic equations. We're still going to use substitution now. All right, So we have the equations y is equal to negative x squared minus x plus 12, and y is equal to x squared plus 7x plus 12. So remember, this means in order for us to have solutions to this equation system, that needs to satisfy both equations at the same time. So since both of these are already set equal to y, I can then take what y is equal to, and I can substitute it into wherever I see y. So I have y is equal to x squared plus 7x plus 12. Well, since I know y squared is also equal to negative x squared minus x plus 12, I can say negative x squared minus x plus 12 is equal to x squared plus 7x plus 12. All right, same thing before. We have a quadratic equation because we have our highest degree is power of 2. So then we want to set this equal to 0 when we're solving for x. We want to keep our x squared positive, so I'm going to add over the x squared. So it'll be plus x squared plus x minus 12, so I cancel all this out. So plus x squared plus x minus 12. So then that gives me 2x squared plus 8x. And then our 12 minus 12 cancels out, so it's just equal to 0. All right, so once again, we could use a quadratic equation if we want, but this one's really easy to do by factoring. First thing we always look for is we take out our GCF. Both has a multiple of 2 in it, so I can take out the 2. And both have an x in it, so I can take out the 2x. When I factor out a 2x out of here, all I'm left with is x. When I factor out a 2x out of here, all I'm left with is plus 4. All right, so the same thing. Whenever we have two numbers that multiply to give us 0, I know that one of them has to be 0. So we can then say 2x has to be equal to 0, because that was one of our factors, or x plus 4 is equal to 0. All right, so then to solve for this, we can then divide it by 2, so x has to be equal to 0, or subtract 4, x has to be equal to negative 4. All right, so now remember, in order to solve for this, we need to have an ordered pair. So this will be written as 0, comma, and negative 4, comma. All right, we need to solve what is our y value. Well, if we want to know what our y value when x is equal to 0, all we have to do is plug it in. So it doesn't matter which one you substitute into. I'm just going to substitute into this bottom one here, because that way my x squared is not negative and it might not trip me up. All right, so then I have y is equal to x squared, so 0 squared, plus 7 times x plus 7 times 0, plus 12. All right, well, 0 squared is 0, 7 times 0 is 0, and 0 plus 12 is equal to 12. So when x is 0, y is equal to 12. All right, and then the next one, I'm going to plug it into the same equation. So we have y is equal to x squared, so y is equal to negative 4 squared, plus 7 times x plus 7 times negative 4, plus 12. So then y is equal to negative 4 squared is 16. 7 times negative 4 is minus 28, plus 12. And 16 minus 28 is negative 12, plus 12 is 0. So when x is equal to negative 4, y is equal to 0. All right, so these are our two solutions, and this is how you have to write it. 0, 12, and negative 4, 0. All right, you cannot just write x is equal to 0, comma, negative 4, and y is equal to 12, comma, 0, because we need to make sure that we're writing them as an ordered pair, because when x is 0, y is 12. When x is negative 4, y is 0. That's a specific order pair that is our solution. All right, that's it for this video, and next we're going to move on to quadratic inequalities.